Hey guys, welcome back to another round of chemistry notes. In this video, we are going to talk about percent composition. So percent composition is the percent by mass of each element in a compound, which is sort of actually a misleading definition because you can do it for elements, but you can also do it for things besides elements. So your percent composition for an element is the total mass of that element in the compound divided by the total mass of the compound, and then multiplied by 100. But since we can also do this for ions, we'll do this for water a couple of times. You can do it for really anything, and in sort of a more generic equation is your percent of the thing you're looking for, your percent composition of the thing you're looking for, regardless of what that thing is the total mass of the thing divided by the total mass of the compound divided by 100, multiplied by 100. So anything you're looking for divided by the total mass times 100. Because it is a percentage, all of your percent compositions should add to 100-ish. You'll be rounding when you do these problems. Maybe it will be 99.99%, maybe it will be 100.01%, but it should be approximately 100%. And lastly, if you aren't told the amount of a substance, just assume that you are using 1 mole. On the flip side of this, if you are told the amount of a substance, use that amount in your calculations. All right, so for example, number 1 here says, find the percent composition of each element in the compound copper 1 sulfide. Just like any problem, the first thing you need to do is find the equation. So copper is find the formula of your compound. So copper is a metal, and sulfide comes from a nonmetal. So this is an ionic compound, which means we need to write the ions. Copper is Cu. This 1 means that the charge of copper is +1. And then sulfide comes from sulfur, which has a 2- charge. Putting them together, we're going to need 2 of the coppers and 1 of the sulfides to make their charges cancel. So our equation will be Cu 2s. Now that we know this, we can start working percent composition. But again, when you do the percent composition of each element, you're going to be dividing it by the total mass of the compound, which we should probably find before we try and work this problem. So the total mass of the compound is going to be the molar mass of the compound. And to find the molar mass of Cu2s, we'll do 2 times the mass of copper, which is 63.55, plus 1 times the mass of sulfur, which is 32.06. When you add those together, you should get 159.16 grams per mole. And since we're assuming 1 mole of a compound, we can really just say this is 159.16. So this is the mass of the total. The mass of the whole thing. We're going to find the percent composition of each element. So we're going to do percent composition twice. Once for copper and once for sulfur. For copper, we'll take the total mass of copper, which is 2 times that 63.55. So that's the total mass of copper over the total mass of the entire compound, which is that 159.16, and then times 100. Typing this in, 2 times 63.55 divided by 159.16 should give you 79.86% copper. Just like any number, you need the number itself your units are the percentage, and then you should say what element or compound you're talking about. So 79.86% copper means we have the proper units. So we know by looking at this already that the percentage of sulfur should be just over 20%, because that's what we'll add to 79 to create 100%. So we'll do the same for sulfur. We'll do our single sulfur times the mass of sulfur. So this is the mass of all of the sulfur in the whole entire compound. Divide it by the mass of the whole entire compound times 100. Plugging that in, 32.06 divided by 159.16 times 100 should give you 20.14% sulfur. So again, it's the piece that we are looking for over the whole thing times 100. And just to double check ourselves, we can add these together. 79.86 plus 20.14. Adding those together, we do get 100%, which is a pretty good sign that we've worked this problem correctly. So we can go ahead and move on to our next problem. Number 2 says, as some salts crystallize from water solution, they bind water molecules in their crystal structure. Sodium carbonate forms such a hydrate in which 10 water molecules are present for every formula unit of sodium carbonate. The resulting compound, sodium carbonate decahydrate, and then you're given the formula, has a molar mass of 286.14 grams per mole. So this is how hydrates form. You get an ionic compound trapping some water in there. The fact that there's no coefficient out front means the coefficient is a 1. So for every 1 sodium carbonate, we have 10 water molecules. And we're asked for the percent by mass of sodium in sodium carbonate decahydrate. So since we are looking at sodium, the part we care about is the sodium. So the top of our fraction will be 2, because we have 2 sodium atoms, times the mass of sodium, which is 22.99, divided by the total mass, which we're given is 286.14, times 100. When you type that in, 2 times 22.99 divided by 286.14 times 100, you should get 16.07% sodium. So if we had 100 grams of this compound, 16 of them would be sodium. It is 16.07% by mass made of sodium. Question B has the same stem. We're still talking about the same compound, but now we are asked for the percent by mass of carbonate. And something that's a little tricky about this problem, something people are tempted to say, is that there are 3 carbonates here, but that's not true. Carbonate, the ion, one of your first 6 weeks ions, is CO3 2-. So this 3 is permanently attached to this oxygen. So if you look, we have 1 carbon and 3 oxygens, and that's it. There are no parentheses 2 or parentheses 4 saying we have 4 carbonates. Since there are no parentheses, since there's no number that comes after the 3, we know that there's in fact just the 1 carbonate. So to find our percent by mass of carbonate, CO3, we will take the total mass of carbonate in this compound, which is just the 1 carbonate. So that'll be the 1 carbon, 12.01, plus the 3 oxygens, 3 times 16. And there's only 1 of these. So we'll take our total mass of carbonate and divide it by the total mass of the whole entire compound. So 286.14 times 100. Plugging that in very carefully, do it in steps. Do your 12.01 plus 3 times 16 and get an answer divide it by 286.14, then multiply by 100. If you've done it all correctly, you should get 20.97% carbonate. So same as before, we have more than one atom at a time that we're looking at, but since the thing we are looking for is carbonate, you put the entire mass of all of the carbonate in the top, divide by the total mass of the whole thing, times 100 gets you your answer. All right, one last problem here. Letter C says, what is the percent by mass of water in sodium carbonate decahydrate? So once again, the thing we want is water, so we'll put our total mass of water over the whole compound. But this time we have 10 waters. So the mass of one single water is 2 times 1.008, because each hydrogen is 1.008, plus 16.00. This is the mass of one single water molecule, but we have 10 of them. So in the top of our fraction, we will take this mass of one water and multiply it by 10, which will give us 180.16 grams of water in 1 mole of this compound. So we will take our mass of water, our 180.16, we will divide it by the total mass of our compound, 286.14. We will multiply it by 100. And then carefully plugging that into your calculator, you should get 62.96% of water. Remember those units. So at this point, we have found the percent by mass of each part of our compound. We found the percent by mass of sodium, the percent by mass of carbonate, and the percent by mass of water. So we can go back, look at our other answers, add them all together, and make sure they add up to 100. Sodium, we had 16.07 plus 20.97% carbonate plus 62.96% water. If you add that all together, you do get 100%. So we can be pretty sure we've done this correctly. All right, at this point, you have several practice problems in your booklet. Go ahead and work through those, remembering to write your formula, find your molar mass, and then go through and solve each question. Keep in mind that there are some questions that might require you to plug into a different place in your percent composition formula, but you can still use your percent comp formula. So work through your practice. When you're ready to check your answers, go ahead and unpause the video. Hopefully this is what you got for your answers. If it is not, you can go back, look over your work, see if you can figure out where you went wrong. Otherwise, you can always check the more detailed key on my website. In any case, once you are comfortable with this, you should move on to the next video, move on to your quest. As always, come into tutorials if you need help. Good luck and happy studying.